All right, here's 6.7, guys. Um, Properties of logarithms. There's a couple here to go over. We've discussed a few of these already. All right, so let's take a look at them, and I'm going to go into some of these problems, and I'll show you what properties we're actually using here, okay? So let's start. Use the properties above to write each expression as a sum or difference of the log. Okay, so I'm focusing on this part here, and I want to try to rewrite this as properties of logs. All right, so something's going on here. So first I'm going to use uh, number 5. So the first property I'm using is log. Make this a little smaller. So the first property I'm using is property number 5 here that says log of b of m times n is equal to log base b of m plus log base b of n. All right, so that's the fifth property here. So I'm going to write this as log. It's natural base, so log u squared plus log of v cubed, right? And there's a natural log here of 10 that you don't have to write. All right, so that's the first thing I do. The second property I'm going to use is this is property number 5 listed above. And the second property I'm going to use here is number 7 here, which says log base b of m to the p power, right? So we have u to the second power is equal to p times the log base b of m. So you're just able to take this exponent and put it in front of your log, which is really powerful in solving for exponents. So for this case, I'm going to bring the 2 in the front, so this is going to be 2 times the log of u. Right? You don't have to write multiplication, but it's implied. And then plus, and then this one, I'm going to bring the 3 in front of here, so 3 times the log of v. And that's how I would write this as a sum or difference. All right, and the same things work with subtraction, and all these properties work the same. So for this one, for b, with multiplication, so I'm looking up here, with multiplication comes addition, with division comes subtraction, right? And like most, rules of exponents, same thing happened. So I'm using that, right? So I'm using the property log. This is number 6 here, property number 6. Log b of m over n is simply just equal to log base b of m minus log base b of n, right? Just using subtraction. All right, so here it is. So I'm going to use log base 3 of a minus log base 3 of b squared. And then I'm going to go back and use the property number 7 again, which is the exponent property. So I'm going to be able to take this 2, like I did in the previous problem, and put this in front. So my final answer would be log base 3 of a minus 2 times the log base 3 of b. All right, so very, very similar in most of these. All right, I'll do a few more, and then we'll kind of move on and see where we end up. All right, so now you have natural log and log use, this is all log, but you could treat these as if these were natural log as well. So not a big deal, right? All these properties apply to natural log as well. All right, so we have natural log of quantity of x plus 1 times the quantity of x minus 5. So if I'm just thinking about, the property here is if you have ln of a times b, then this would be ln of a plus ln of b. Right, that would be the property I'm using. So it's the same thing. So ln of a, which is x plus 1, plus ln of b, which is x minus 5. So that's all it is. Right, so this x plus 1 is kind of my a. This x minus 5 is my b, in a sense. All right, division here. So I have division. And the first thing I'm going to do is I'm going to rewrite this square root sign. So I'm going to write log base 5, and I'm dividing a cubed over b, and it's all to the 1/2 power. All right, so that's the first thing. So I'm going to rewrite that square root to the 1/2 power. All right, so first property I'm going to use is I'm going to bring this 1/2 down in front of my log. So this will give me 1/2 times the log of a cubed over b. So 1/2 is multiplying all this. All right, so and then I'm going to say, well, I can still break this down. So 1/2 times, well, I can break down log a cubed divided by b, and this is really just going to be log base 10 of a cubed. Division implies subtraction, and then log of b. And again, all this is still, right, all being multiplied by 1/2. And then one more property here, right? So I'm going to take that 3 as an exponent, I'm going to put it in front of here. So I got my 1/2, that's starting with. And then this is going to be 3 log of a minus log of b. And you can leave it like this, or you could take one more step here and just distribute the 1/2. So you'll have 3/2 times log of a minus 1/2 times the log of b. So both are suitable answers. All right, let's take a look at another one. And again, they're all going to be very similar. I'm going to do 2 more here, and then I'll see what else we got. All right, so ln, natural log versus log, same thing. So the first thing I'm noticing is I got some square roots, cube roots in this one. So I'm going to rewrite this. So I have ln and I have a, b to the 4th over, and I'm going to write this as c to 2/3. All right, just to get rid of my radical sign. All right, so I'm recognizing my division sign here. So I'm going to break that up with subtraction. So I got ln. So ln, my numerator, which is a, b to the 4th, minus my denominator, ln c 2/3. Okay, cool. Couple things going on. Well, in this one, I still have a product here. So I could break this down again. So I have ln, natural log of a, plus natural log of b to the 4th. Right, that's what all this is going to break down into. And minus my natural log of c to 2/3. And then one more thing I'm going to notice here is I have an exponent of 4, which could come in the front, and an exponent of 2/3, which could come in front of the log. So I have natural log of a plus 4 times the natural log of b minus 2/3 times the natural log of c. And it's expanding this, right? So this is expanding these logarithm functions. Let's do one more, and then we'll try some condensing ones. Here we go. So I got log base 2 x squared times the square root of 1 minus x. So again, my first step here, I'm going to rewrite this as log base 2, and I got x squared times 1 minus x, and this is really to the 1/2 power. All right, so just rewriting those separately. All right, so we got multiplication, so let's address this multiplication first. So multiplication implies addition, so log base 2 of x squared plus log base 2 of 1 minus x to the 1/2 power. And not much more to do here. I'm going to take the exponent, bring it in front, take this exponent, and bring it to the front. So 2 log base 2 of x, done, plus 1/2 log base 2 of 1 minus x. That's it. Can't do anything else. All right, so this is me using the properties above to expand, these log functions. Now let's go backwards. Right, now we're going to condense these. So they're already expanded, and now let's put them back together. Okay, so multiplication implies, addition implies multiplication, right? So addition implies multiplication. So I'm going to rewrite this as one log function, and I'm going to take 3u and multiply it by 4v. And I'll just simplify that one more time. 3 times 4 is 12, and u times v is uv. So this is just going to be log base 10, right, natural log of 12 uv. Subtraction is going to imply division, okay? And I'm going to look at that, and I'm also going to see, okay, well, there's a 2 in front, that should be an exponent. So I'm going to take care of that one first. So I'm going to say, okay, this is log base 2 of u squared. So there's nothing in front of the log, minus log base 2 of v. Okay, cool. All right, and now I'll hit the subtraction sign there. That implies division. So writing with one log, so log base 2, and it's going to be u squared over v. Okay. Subtraction again. So ln, you could leave it as square root of x or 1/2. No, I'll just leave it as square root of x for now. Minus, and again the 3 is going to come back up as an exponent. So ln of x cubed. Subtraction implies division. So natural log square root of x over x cubed. Right? And we can simplify this actually a little bit more. So square root of x is x to the 1/2 power, and this is x to the 3rd. And you could go and subtract the 1/2 from the 3rd, and you'll be left with ln of 1 over x to the 5/2 power. Either one of these would be fine. Any one of these answers can be okay. All right, but that's how you condense. Next one. We have some subtraction going on. So I'm going to have log base 2 1 over x over 1 over x squared. So we have a complex fraction here. We can divide this, and remember, I'm just going to branch off on the side here. This is really 1 over x divided by 1 over x squared, or 1 over x times x squared over 1, which just simplifies to x. So really this is just log base 2 of x. Okay, got a couple more looking a little more complicated, but not too bad. All right, so we got addition here, so that implies multiplication. And then we got subtraction here, and that implies division. All right, so I'm going to go left to right. So I'm going to combine these first two. So we got ln, and this is x over x minus 1 times x plus 1 over x. And then of course, then we have the division here. So, and then this is all over. I'm just going to write this ln a little further out. So ln of all this, and then division, and then I'm dividing by x squared minus 1. Right? And that's pretty much the rules of the logs. But here, all this is going to bring you back to just rationalizing denominators and all that good stuff. So those simplify out. So I'm going to do a little side math here. So you're left with x plus 1 over x minus 1. And this is really divided by x squared minus 1, or x plus 1 over x minus 1, times 1 over, and if you factor that, x plus 1 is x minus 1, right? It's going back to all that. And then your x plus 1 simplify, and you're left with 1 over x minus 1 times x minus 1, or 1 over x minus 1 squared. So your final product here is natural log of 1 over x minus 1 squared. So here's the rules part, right? This is all the rules that we applied. And then this is the, and this part is the simplifying part. All right, and so it's not bad. So we'll work on a simplifying, not a big deal. All right, so let's think about the rules here. So noticing this subtraction sign, so I got some division. So this is the log of dividing two things. Okay, well, my numerator is going to be x squared plus 2x minus 3 over x squared minus 4. And there's a lot of factoring going on in there, and I'll do that in a second. And then my denominator is x squared minus 7x plus 6 over x plus 2. All right, so we got keep, change, flip here. So I'm going to start factoring. So now I got all this, and my next step here is to simplify. All right, so let's just get that all out. Okay, so this is going to be x. This is going to factor, right? X and x. We got 3 and 1. We got positive 1, negative 3. All over x plus 2 and x minus 2. Times, I'm going to keep, change, flip. So x plus 2 goes in my numerator. And then my denominator is going to be x minus 1 and x minus 7. Just joking. X plus, it's going to be x plus 1 and x minus 7. Just joking again. It's going to be x minus 6 and x minus 1. Sorry. All right, so what do we got? We got x plus 2 simplifies with x plus 2. We got x minus 1 simplifies with x minus 1. And then we're just left with natural log of my numerator has an x plus 3 in my numerator. And my denominator has an x minus 2 and an x minus 6. Right, so it's the log of all that. Right, so the properties are not bad, right? Subtraction goes to division, multiplication goes to addition, and then you just got a little bit of simplifying to do. All right, I'll do one of these and I'll let you guys do the other one here. All right, so we got some craziness going on here. So I'm going to do is tackle this piece by piece. Okay, so let's tackle this one first. I'm going to simplify this all the way. So I noticed the 8, so the 8 is an exponent. Right, and I notice my square root, and I'm going to rewrite the square root as an exponent as well. So I got log base 2. All right, this is 3x minus 2 to the 1/2 power. And then when I bring the 8 up, the 8's going to go back to there. So simplifying this as is, this is log base 2 of 3x minus 2. And if I multiply 1/2 times 8, I get this is to the 4th power. Okay, so that's done. Minus nothing really needs to be simplified here. And plus, and then this is log base 2 of 4. This actually can be simplified. Right, what is log base 2 of 4? So 2 to what power is 4? And it's just going to be plus 2. Okay, cool. That's easy enough. So I don't really have to worry about the plus 2. Now I'm just going to really focus in on this part. See the subtraction here, which implies division. So I got log base 2 of 3x minus 2 to the 4th over 4 over x, and plus 2. And then if I want to clean this up, this is just log base 2. So on the side here, remember this is 3x minus 2 to the 4th times, keep, change, flip, x over 4. And then you're just left with, you can just put the x, x, this is just x, 3x minus 2 to the 4th, all over 4. All right, let's see what else we got. So then we have log 2, and you got x to 3x minus 2 to the fourth over 4. Okay, so this is pretty good. There's something else I could have simplified throughout the way to make this even more simplified. All right, so here's what I'm looking at. I'm going to erase this a little bit. Sorry. So I'm going to erase this a little bit here. And I'm going to focus in on this step here. And you could do this here, or I could do it down here, but I'm going to do it either way. So if I rewrote this, right, this is x times 3x minus 2 minus log 2 4. Right, since I have division here, and again, I could have done it in this step here or here, so it doesn't matter which step I do it in. I'll show you the other one. And then I'm going to bring my plus 2 here as well, because I don't want to forget that. So I have log base 2 of x times 3x minus 2 minus, and log base 2 of 4, again, is 2, and then plus 2, which would then just cancel these out, and your final answer is log base 2 of x times 3x minus 4. So that one got a little entailed here. So I had to see that, recognizing that there's a log 2 and a 4 here, that you should be able to simplify a little bit more. All right, so you could have done there, and let me erase a few steps here, because let me show you where else you could have done this. So hopefully you got that down. So I'm going to erase a few steps here. I'm going to take this and delete this. All right, so here. All right, so this first one's good. So I got log 2, 3x minus 2 to the fourth minus, and then here I'm recognizing what I'm hoping you guys can recognize is the 2 and a 4 here. All right, so if this was just log 2 of 4, then you're going to get an answer. So you're subtracting. And what I'm going to do is I'm going to break this up. So be careful when you break this up, okay? So the subtraction sign has to go to all of this, even when I break it up. So when I break this up, it's log base 2 of 4 minus, right, because it's division, log base 2 of x. And then my plus 2 here at the end, which is a little challenging. Okay, so let me backtrack and write everything I have. So 3x minus 2 to the fourth, right? I'm just bringing this down. Okay, minus, so I'm distributing the negative here. And log base 2 of 4 is 2. And then distribute the negative here. Plus log base 2 of x. And then plus 2 at the very end. And then the positive 2 and the negative 2 will cancel out. And you're left with log base 2 of 3x minus 2 to the fourth plus log base 2 of x. Addition implies multiplication, so writing this with one log is just log base 2 of x times 3x minus 2 to the fourth. All right, a lot of properties going on in there. Somewhat challenging, but doable. All right, this is change the base formula. I'll show you one quick one and then call it a day. Some time ago, well, if you have a scientific calculator, you cannot change the base on the calculator. You have to use a base of 10 or a natural base of e. If you have the graphing calculator, you can do alpha window and get your base on there. Okay, but in this case, if you needed to solve something like this, you would have to use a natural base here. So this is what this is saying. Log base b of m is equal to log base a of m. So I'm looking at this. Log base b of m is equal to log base a of m over log base a of 10 of b. Okay, and the natural log, and we can use any log. So I'll just use log 10. Okay. So to use my formula, right, this is log base b of m is equal to log base a of m over log base a of b, right? And this m is m, and this b is b. So log base 3 of 21, can't do any scientific calculator, but if you want to use the scientific calculator, so you do log, we'll use base 10, no big deal. So log of 21 over log of 3. And whether you put this or this in your calculator, you will get the same exact decimal. All right, and this is called your change of base formula. And you can just use your calculator as well. All right, so I'll end there. There's a couple more you could do on there as well, but that's pretty much going to be it.